We're now going to learn how a definite integral is defined as the limit of a Riemann sum, go over some properties that you'll need to know, and walk through an example. Let's begin with the definition of the definite integral. For a continuous function f of x on a closed interval from a to b, the definite integral of f from a to b is defined as the integral from a to b of f of x times dx. And this is equal to the limit as n goes to infinity of the Riemann sum I goes from 1 to n of f of x sub I times delta x. A really important thing to remember is that a definite integral equals a number. It does not equal a variable. Let's now go over the notation. This symbol is the integral sign. It is shaped like an S because integrals represent the sum of the area under a curve. A is called the lower limit of integration, and B is called the upper limit of integration. The function that we're integrating, f of x, is called the integrand, and dx is the differential. X sub I star then is any sample point chosen within the subinterval. Let's now go over 3 really important properties of definite integrals. The first property tells us that the integral from a to b of f of x dx is equal to minus the integral from b to a of f of x dx. You just have to remember, if you switch the limits of integration, you have to multiply by a negative. The second property tells us that the integral from a to a, notice that that is the same point, of f of x dx is equal to 0. The reason for this is that if you're integrating from a to a, your x value is not changing, so your delta x is equal to 0, and the area under your curve has a width of 0. The third property tells us if you have some point c between a and b, you can split up your integral. And you can write the integral from a to b of f of x dx as the integral from a to c plus the integral from c to b. Let's now walk through an example. In this example, we are given a limit, and we are going to express the limit as a definite integral on the given interval. Our limit is the limit as n goes to infinity of the Riemann sum I goes from 1 to n, x sub I star divided by x sub I star squared plus 4 times delta x. And our interval is from 2 to 5. The limit of this Riemann sum is equal to the integral from a to b of f of x dx. This function here is f of x sub I star, so to find f of x, we just get rid of the I and the star. And then over here, we can see that a is 2 and b is 5. So we can write down that this is the integral from 2 to 5 of x, all divided by x squared plus 4, and then instead of a delta x, we're going to have dx. And there's our answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.